Okay, now in this video, let's try and understand another method of directly using ROS RCLCPP code directly. Because this is ROS and RCLCPP is for C++, we can directly use RCLCPP in our code of Gazebo Sim plugins. Okay, but the main thing is that everything that we already know from ROS nodes and subscriber, publisher, action, service, everything is the same API can directly be used in the plugin as well. But the main thing is that there is a threading thing that we need to understand for to use this plugin. So we'll need to create a new thread. Let's try and understand why we need to create a new thread on the plugin. Other than that, everything is same and it is going to work. Okay, let's try and understand that part. Okay, so what happens if you know ROS2, then basically you need to create this pin when you're subscribing, right? So that your subscriber can help the callback messages being received. So this is, I'm just for example, I'm considering the single threaded one. So on single threaded one, we just add the node, then we run this step is very important, executor dot spin. So what happens, this actually blocks the main thread, the thread on which the RCL is running. It blocks that up. Why? Let's understand this. This is an image from ROS2 executor, and this wonderfully explain why it's blocked. So this is the executor, okay? And whenever you publish on some topic, let's say goal, command, odom, any topic, then what happens? Then this goes to executor. Then if there are two messages, like message number one, message number two, then this first message that's over there, this first get processed on the subscriber side, the subscriber callback that we write, that this get first processed. Then when this is processing, you need to make it wait, right? Wait is basically you have to block the main thread, then only you can wait. Do you get this? That you need to block the thread, then only you can make it wait. So you block the thread, then and you wait for this process to get executed, the one message that you send firstly, that once it get executed, then you will send this up, and if any other message is there again, then you will wait. So because of that, what happens, the spin main purpose is to block the thread until another message is processing. Because of that, it blocks the thread whichever it attached to. So that is a problem. We'll understand why. Okay, so if you go down, so if you remember this interfaces, we use this a lot. So the problem here is that this three interfaces runs on loop, and it runs on the loop with Gazebo Sim itself. So it's a part of Gazebo Sim, right? So this, if even if we are using, let's say we are using update, only update is there, these two are not there. So it is going to loop like this, right? And it keeps on looping. But the problem is that if we use executor spin, then when your thread start to execute, it is going to block at this point. So it blocks, that means even anything working on Gazebo will stop like this for a moment, because you have blocked the main Gazebo thread itself. This runs on the Gazebo thread, right? So on the main thread of Gazebo, you just block the scene, and then it will unpause, and so either what will happen, Gazebo Sim will stop for some time, and then it will start basically it will have some unsmooth motions. That is a problem, and because of that unsmooth motion, we can't use this executor, and many times you will see that executor even falls the code. And what happens after, even your code may not build if you write the executor on the main thread, because you should not be blocking the update rates, whatever it is. You should not block the loop of Gazebo. So how we resolve this problem? So the solution is very simple. I hope you know how threading works. Like thread is means a function that in which your code is, like main is one function. There could be another thread, a function that runs on it. Okay. So then instead of having main, what are we going to do? We are going to create one another thread. So we use this standard thread for creating threads. If you know, we use the standard thread for creating new threads. So this is the main thread that's still going to run as it, which is the Gazebo's thread. This is Gazebo Sim thread. It keeps on running, and instead of running ROS this pin on the main thread, what we'll do, we'll make a new thread out of it. We'll got this thread CPP thread for ROS executor, for running this ROS executor, this executor, this pin executor, for running this. create new thread using the standard threads. Standard thread is a very basic C++ thing that we use for creating any threads. Okay, so now on this thread, because now this thread is running different, this is a different thread, right? And this is a different thread, because of which what will happen now, if we run executor on the new thread, it is not going to block this thread. So this is called multi-threading. If you know, this is called multi-threading. If you do not know, just read about it. It's not a complex thing. It's just that now we have two different threads where each of them can run independently. Okay, so that's the logic over here. So now, as it is not blocking harming gazebo because both are different thread, and also your everything related to ROS is going to run on this thread of CPP thread. So your executor spin, so basically the executor spin is the one that has this ROS callback, right? Subscriber callbacks. So this subscriber callback that we see over here on this ROS subscriber messages, this is a subscriber callback function, right? So this callback will also run on this thread because the spin has got here. So everything related to ROS will run on the another thread. I hope this is clear. This is the only thing that we need to handle it properly. And then you will be able to write your direct ROS rclcpp. You can directly use it on Gazebo Sim plugins. Okay, so that's the thing. Now let's see the code, how what is there in the code. So we define this ROS node. This simple, we make sure ROS rclcpp node. This is the ROS node name that we have given. Then we make this ROS executor. You can make multi-threaded executors or single-threaded executor. If you go on this link, you can understand what is multi-threaded executor and what is single-threaded execution. But in simple words, the single-threaded executor can run one subscriber at a time, and one subscriber is done, then it will run another subscriber like that. Okay, but in case of multi-threading, like 2-3 subscriber can run at a time. So 3-4 subscriber can run at a time. That's the main difference. If you want to go on technical details, just check this link out. So then you define this thread, and then this is single threaded. Now you add your node, your ROS node, you add into ROS thread executor. And okay, then before even this, we need to first initialize the ROS. I haven't mentioned this line over here, but I can show you on the code. This is also important. So what happens, even before doing anything on the config, you first need to initialize this ROS. It will check if ROS is okay. That means if ROS is initialized or not. If it's not, it will initialize rclcpp in it. Then we come to this code that I'm going to explain over there. Okay, so you initialize first before doing anything. Yep, so we were talking now. You made your ROS node and you made your executor, that is single threaded executor, and then you added your node to that executor so that it can spin on. But as I was saying, we need to create another thread. How we do that? We use this lambda function. So this, understand, this is like this lambda function. So this is the input that we are using for this to access our, this is a pointer, right? So we need the input. So we're using this pointer, and using this pointer we execute the ROS executor from the class, and then we execute the spin part of it. So basically this act as a variable, name using lambda. This act as a variable name which actually includes what? Includes this ROS executor only. So it's just a way of writing it out. Okay, so this actually has this, then this ROS threaded spin you add on to the standard thread. Now once you add on to the standard thread, it is going to create a new thread that we just discussed. So once you add using this standard thread, you make your ROS executor. That's the same thing this actually does. This ROS thread spin, this is ++ thread creates a new thread for ROS spin Torah. And what it has internally is this ROS executor. Basically it runs inside this. So this is the function. The function name is this, and what is running inside the function is ROS executor spin. So now everything that runs on the ROS is transferred to a new thread, and it can run over there. Now this is the H file, and now what we have added on is rclcpp because we are using that, and standard messages for float 64 because we are directly using it. and then everything over here is just same, nothing difference on the plugin that we wrote 2-3 videos back, right? So nothing is different on that plugin side. And then we are using model name, and now we added ROS topic name to get the ROS topic, and then everything we have defined ROS node, and then we have defined on ROS callback. This is ROS callback to get the data on this topic. Okay, so standard messages is the data. This is ROS subscriber callback. And then on the C++ file you will see this. So basically for model name we are getting the model name from here, and for ROS2 topic name, if you see the launch file of it, this is the direct ROS launch file, not the launch file, sorry, the world file. If you see directly the world file, now the model name is still the same, this the model name from this, and the ROS topic name is basically the name that we have added on. So this name we have added for ROS topic, that we are directly using on over here ROS topic name, and then ROS topic name is added up. Now its z velocity, this variable is not there, but it initializes it to 0. Okay, now we just discussed this was initialized, and then the same thing that I explained you, everything, and I've written in the doc, in the code comments as well, the same thing, this all things I've just explained you, everything is same, nothing different. Now once this is there, on this, on the ROS message callback, what we are doing is we are just adding this on the subscriber create subscriber. This is normal ROS CPP subscriber, right? So on this we just mentioned the our callback function, ROS callback function, and then it takes the value directly from here, and then it assigns to this, and then z velocity variable get updated, and then our code runs. The simple thing, nothing we have changed, we just added on direct ROS using rclcpp. The same entire code that I just told you exists over here, you can check it out, and this is the entire code, everything is same. And either you can use single threaded executor or multi-threaded executor. Here we don't need multi-threaded executor, we're just using single subscriber, and it's not very heavy, so we can use the single thread subscriber. Then on the code is everything is same, defined, configure. Now we call this as move model direct ROS plugin, and everything is there. And on you just update the message, everything on over here is as well as same. Then we set component data, and we set the linear velocity command. Okay, now I've already built the code for us. I've already built this code. I've kept a source as well. So let's do ROS2 topic, sorry, ROS2 launch, and our model move model direct ROS is the launch file name. And okay, the display thing, I forgot to add the display x host plus, sometime it happens, normal, we launch it, I got the display, everything is working. Let's do ROS2 topic list, and C is our topic there. Yeah, our topic is there. Let's do the same thing, nothing different, we are just publishing on the topic, ROS2 topic, then the message, then the topic name, then standard message, then the message name, then we just write the message, and we do 1.0, and it's going up, it's going up, it's going up, and you'll see this getting published on this, and it is getting published faster, right? Now this is getting published, and everything on this is running on a different thread, and now our box is moving faster up and down. You can check the speed. Yeah, sorted, done. This is it. Now we understood both the method that we can use for making this ROS communication happen using ROS GZBridge, and now the direct method of rclcpp. So as sometime what happens, there are some messages that's not present on ROS GZBridge, then you can directly use this direct method that I just explained to you. Or sometimes you do not want to overcomplicate things, having those messages run from GZBridge and then convert it into ROS topic. Directly you can include your ROS topic. It's just your design, which how you want to make the code work. It's just that.